everyone, let us solve some problems on Gaussian bivariate random variables. Let us take the first problem. Given the bivariate PDF fxy x comma y is equal to 1 divided by 1.42835 e to the power minus x square plus 1.4xy plus y square divided by 1.02. For all values of x and y varying between minus infinity to plus infinity, what are the PDFs for x and y? Let us try to factorize this x square plus 1.4xy plus y square. So here we have 1.4xy is equal to some constant t into y into 2. So here it is y and y get cancelled out. So therefore t is equal to 0.7x. So that 0.7x is taken here. So we have y plus 0.7x whole square plus 0.51 whole square. So 0.7x whole square will give us 0.49x square, and we have to have 0.51x square so that we can get x square. So therefore you have here 0.51x square. So let us rewrite the PDF bivariate PDF fxy, that is equal to 1 divided by 1.42835 e to the power minus y plus 0.7x whole square plus 0.51x square divided by 1.02. Now let us try to find the PDF for x, that is integral of fxy x comma y dy. We have to integrate the PDF with respect to y. So let us rewrite the PDF value what we have derived here in the equation. So we have e to the power minus 0.51 x square divided by 1.02, because it is a constant, because we are integrating with respect to y. So divided by 1.42835 e to the power minus y plus 0.7 x whole square divided by 1.02. Let us integrate this with respect to y. We have 0.51 divided by 1.02. So when we divide it, we get it as 0.5. So e to the power minus 0.5x square divided by 1.42835 integral of e to the power minus y plus 0.7x whole square divided by 1.02. We need to integrate this with respect to y. So we want to make this in the form gamma functions form. We have gamma functions defined as integral of z to the power n e to the power minus z square by 2 dz is equal to 2 to the power n plus 1 by 2 divided by 2 gamma of n plus 1 divided by 2 for even n. For all n, this is 0. So we want to get this into the form something like u square by 2. Therefore, we write this as u by u2 is equal to y plus 0.7x divided by root of 1.02. So dy is equal to root of 1.02 divided by 2 du. U square by 2 is 0.7 whole square divided by 1.02. Let us substitute these values in this equation. So we have e to the power minus 0.5x square divided by 1.42835 root of 1.02 divided by 2 integral of e to the power minus u square by 2 du. In this case, you can observe here it is u to the power n value is equal to 0. So it is 2 to the power half divided by 2 gamma of half. Therefore, fx of x is equal to the power minus 0.5x square divided by 1.42835 root of 1.02 by 2. It is integral of minus infinity to infinity e to the power minus b square by 2 du. So here you have minus infinity to infinity. So we need to write this as e to the power minus 0.5 x square divided by 1.42835, and here n value is equal to 0. So 2 to the power half gamma of half into root of 1.02 by 2, that gives you e to the power minus 0.5 x square divided by uh, root 2 y. X value varying between minus infinity to infinity. Similarly, we can obtain fy of y, that is equal to e to the power minus 0.5 x square divided by root 2 y for all values of y varying between minus infinity to plus infinity. Let us take the second problem. Given the bivariate period fxy is equal to 1 divided by 1.73215 e to the power minus x square plus xy plus y square divided by 1.5 are all values of x and y between minus infinity to infinity. What are the periods for x and y? Check whether the integral of fxy x comma y dx dy is equal to integral of fx of x dx is equal to 1. In the last problem, whatever procedure we have followed, same procedure we need to follow here. X square plus xy plus y square has been factorized here as x plus 0.5 y whole square plus 0.75 y square. So therefore, I can rewrite this equation as 1 divided by 1.73215 e to the power minus x square plus xy plus y square by 1.5. So that has been substituted in this equation. So we have fy of y is integral of bivariate period with respect to x. So this equation is being substituted for bivariate period. 0.75 divided by 1.5 will give us 0.5. So e to the power minus 0.5 y square divided by 1.73215 integral of e to the power minus x plus 0.5 whole square divided by 1.5 dx. Let us put u by root 2 is equal to x plus 0.5 divided by 0.5 y divided by root of 1.5. So that will give us dx is equal to root of 1.5 divided by root 2 du. So root of 1.5 by 2 du. So u square by 2 will give us y plus 0.5x whole square divided by 1.5. Let us put the value here in the equation. So we have e to the power minus 0.5 y square divided by 1.73215 root of 1.5 divided by 2 integral of minus infinity to infinity e to the power minus c square by 2 du. Fy of y is equal to e to the power minus 0.5 y square divided by 1.73215 root of 1.5 divided by 2 integral of e to the power minus u square by 2 du. Now let us apply the gamma function theory. So we get this as 2 to the power half gamma of half. Gamma of half is root 5. So when we simplify this, we get this as e to the power minus 0.5 y square divided by root 2 pi. That is, y value will vary between minus infinity to infinity. Similarly, we can derive for PDF for x. Fx of x is equal to e to the power minus 0.5 y x square divided by root 2 pi, x value varying between minus infinity to infinity. Let us try to find the CDF fxy at infinity comma infinity is a double integration of the bivariate PDF, once with respect to x, second time with respect to y. Let us substitute the PDF for bivariate PDF given in the problem as 1 divided by 1.73215 e to the power minus x square plus xy plus y square divided by 1.5. We have already integrated this with respect to x, and we have obtained in the previous slide as e to the power minus 0.5 y square divided by root 2 pi. This has to be integrated with respect to y. Let us put this as u divided by root 2 is equal to 0.5 pi y. So that is du is equal to root 2 times root 2.5 in dy. So that is equal to integral of e to the power minus u square by 2 root 2 pi du. This is 2 to the power half gamma of half. Gamma of half is root pi, and 2 to the power half is root 2. So they will get cancelled out, and we get as 1. That we have verified. Let us solve the third problem. A figure is given here in the xy plane, and the PDF is defined only for the shaded portion, and the PDF is given as a constant c, elsewhere it is going to be 0. And we need to find the value of c, and also we need to evaluate the PDF x11, find the PDF fx of x and fy of y, and we need to specify whether x and y are independent. Now let us try to find, we know that the PDF for the shaded portion is given to us, but let us consider this entire region, this region, and we'll divide this after considering this entire region, then we'll divide it by 2 in order to get the shaded portion. So therefore we have written it as 1 by 2 integral of x value varies from minus 2 to plus 2, and y value will vary from minus 2 to plus 2, and the PDF value is given as c. So dx dy, when you integrate this, you will get this as 1 over 2 c into 4 into 4. So that is equal to 1. So therefore you get c value is equal to 1 by 8. Let us try to find the PDF at 1, 1 that it can be obtained by integrating the fxy, that is given as 1 by 8 dx dy, and as I told earlier we need to divide this by 2. That we get the resultant as 9 by 16. Now let us try to find fx of x, that's the PDF of x, and PDF for y, and that here it is integral of y value varying from anywhere here to 2. So therefore y to 2, 1 by 8 dy, that gives you 1 by 8 2 minus y for all values of y varying from minus 2 to 2. Fy of y can be obtained by integrating the PDF with respect to x. So we have from here it is 1 by 8 x plus 2, because the value of x can vary anywhere from minus 2 to x. So fxy is 1 by 8. So when I multiply fx of x, fy of y, I get this equal to 1 by 64, 2 minus y, x plus 2. And if I want to get fxy y, I have to doubly integrate the PDF. So when I do it, I get this as 1 by 8, 2 minus y, and x plus 2. Since these two are not equal, we can say that x and y are not independent. Thank you. In the next video, we will study on sum of IID random variables.